Okay guys, this particular lesson is just going to introduce us to organic and inorganic compounds quickly, and each of those is going to be covered a bit more in depth in their own lessons. So, uh, we're going to categorize our biological molecules into organic and inorganic. And our really big emphasis here, as always, is the fact that organic is going to refer to the fact that these molecules or these compounds are going to contain carbon. In addition, they also contain hydrogen, which is important for us to note. So these organic compounds, what we're really looking for is that they're typically containing carbon, hydrogen, and other elements. Versus our inorganic compounds, which are rarely going to contain carbon. Notice that rarely and not never. Because, for example, carbon dioxide is going to be an inorganic compound and it contains carbon even though it's inorganic. Another distinguishing factor for us is the fact that these organic compounds are usually going to be larger, and that's because of carbon's bonding abilities. And what that means is that carbon, as we previously stated in another lesson, is that carbon typically forms four covalent bonds, four bonds with other atoms. And because of that bonding ability, it's going to tend to create a larger molecule or a larger compound. Because once it starts to bond, let's say that it's going to bond with oxygen. Oxygen is itself going to bond with two things, so another bond is going to be formed. If we have a hydrogen here, what if this is bonded to another carbon which needs to bond with other substances, and so on. So that carbon factor really does play into building a large number of bonds, and the more bonds that are needed to be created, the larger the molecule is going to be. Naturally, if organic compounds are going to be our larger molecules, our inorganic are going to be smaller, and that's because they typically are not going to contain carbon, so they're not going to be looking to form four separate bonds. Another important characteristic for organic versus inorganic compounds is that organic compounds, some of them are actually going to be able to dissolve in water. And even though they're dissolving in water, we're considering them to be non-electrolytes because they're dissolving. They're not separating and breaking apart. Right? Dissolving meaning they're just kind of disintegrating into the water. Think of it that way. They're non-electrolytes. No ions are being formed, right? Remember, electrolytes form ions in water. And another important thing is that most of them are going to dissolve in organic liquids. Organic liquids, an example being ether, right? These inorganic compounds, however, are going to dissociate. And by dissociate, I'm really talking about they're going to separate, right, into their separate components in water. So those that separate in water are going to be considered electrolytes because they're going to form ions when they split apart. So the idea that sodium and chlorine ions are formed, all right, inorganic compounds, they're going to separate that way. Our organic compounds are four major classes, which shouldn't be any surprise, are our carbs, proteins, lipids, and nucleic acids. This should be a review from biology, and we're going to cover this a bit more in another lesson coming up, but really you guys should be very familiar with this. Examples of our inorganic compounds commonly associated with anatomy and physiology. Obviously we have water, oxygen, carbon dioxide, and then we have those inorganic salts, right? The salts that are crucial for body functioning, right? So really in our inorganic compounds here, there's plenty of other things, but we're focusing on the ones that are important for the human body. Wow, bad handwriting, guys, sorry. So these are important for the body. Keep in mind, guys, that we are in anatomy and physiology, so the things that we're discussing are really directly relevant to human anatomy and physiology, and we're not just talking about the world as a whole. We're trying to kind of zone in on one specific thing, being the body. So recognizing that water, oxygen, and carbon dioxide are obviously three critical inorganic compounds when it comes to the human body, and inorganic salts, which we'll talk about a bit more later, are also crucial for body functioning. This wraps it up for our little introduction to organic and inorganic compounds. If you guys have any questions, please feel free to see me.